Hi, Ray Nolan, Specialized Solar Systems. Recently, our commercial team completed an energy solution for the George Surgical Center and the Otaniqua Eye Clinic. In 2023, when the clients approached us, we found ourselves in a very high load shedding period in South Africa. And we designed the systems after completing data logging to have battery capacity to carry both facilities through a 4-hour load shedding period. Right now in South Africa, we found ourselves in a different energy environment and we are not experiencing load shedding anymore. What we are now doing with the battery capacity is through scheduled charging and discharging, we are taking away the peak tariff periods that commercial buildings and commercial facilities are charged. So we use the sun to charge the battery during the day and discharge it during the peak tariff period in the evenings. And then we use the off-peak low tariff period in the middle of the night to charge the battery again and discharge it early in the morning before the sun comes up. In this way, we are allowing the system to be at its most efficient and to increase the return on investment for both facilities. On my left here are the 4 Victron 450-200 MPPTs, the charge controllers. Each one of these has 20 555 watt panels connected to it, and they are situated on the roof of the hospital and certain of them on the carport structures outside. This is connected to the DC bus, which encircles the room, and then on the right-hand side and the back of the wall are the 9 15 kVA Victron Quattro inverter chargers. So there are 3 inverters per phase, so it is a 135 kVA system. Then behind me here are the 2 battery stacks, the lithium iron phosphate battery stacks. Each one of these is 90 kilowatt hours, and so the 2 stacks together total 180 kilowatt hours. Their cables run down that cable tray at the back and connected to the DC bus. What you can see behind me here are our Fronius grid-tied inverters. They are connected to solar array out on the carports. These inverters are supplying the load at the moment. That can also be seen on the VRM, the Victron remote monitoring display here, which is connected to the Serbo GX of the system. This is the AC board that connects the entire energy system with those 2 cables up there. It is a hybrid system, so it's connected to the municipal supply and supplying the load of the hospital. It's also integrated into the backup generators because each medical facility has to have a main backup generator and then a backup to the backup generator. So the entire system is integrated with main supply, solar, and then in an absolute emergency, the backup generators. Currently, the entire load is being supplied by solar and no power being taken from the municipal grid.